The next confidence interval is for population proportion. We still have the same data and the data columns are named. Okay. Now let's first look at the formula. So given a population has S or no values, we define lowercase p as the proportion of S values in the data. Now we take a sample of size n, and p bar is the proportion of S values in the sample. So p is the proportion in the population, p bar is the proportion in the sample. Then the confidence interval is given by this formula, p bar plus or minus z, and since this is for a p, it's always z. You don't use t in the case of population proportion confidence interval. Then this is the standard error of p bar, and that's given by this formula. Okay, so z times the standard error is our margin of error. So confidence interval is p bar minus margin of error is the lower limit. The upper limit is p bar plus margin of error. So let's look at how we're going to do this. And this time, since this is for population proportion, we have to set up the formulas one by one. We cannot use data analysis for this. So here we have we want, okay, in this example, we want to develop 98% confidence interval for the proportion of automobiles manufactured in these 5 countries with 6-cylinder engines. Okay. Okay. Now let's define what S is in this population. That is automobiles with 6 cylinders. So that is our S. So P is the proportion of automobiles with 6 cylinders manufactured in these 5 countries. Okay, so we have a sample of what, 38 observations. So n is 38. So n is 38. Let's put that n here. Okay, so number of automobiles with 6 cylinders is, we have to look at how many observations in this column called cylinders is equal to 6, and we can do that using the count if function. Cylinders comma 6 will give us how many observations have 6 cylinders. So of the 38 total number of observations, 10 have 6 cylinders. So P bar here is sample proportion of automobiles with 6 cylinders, and that P bar is the number of automobiles with 6 cylinders divided by the total sample size. That is our P bar. So let's format it. Now standard error of P bar is that formula. So that is square root of, we have a function called Ch08 in Excel. Okay, then P bar, okay, P bar is right there, times 1 minus P bar. So that 1 minus P bar should be in brackets, divided by sample size n. This is our standard error. And the confidence interval we want is for 98%, and that 98% is the middle probability in the normal distribution. So that is equal to 1 minus alpha. But what we need is a cumulative probability to find the z value. So we have to find what alpha is, which is 1 minus that is the 2 tails put together. Then 1 minus alpha over 2 will be the cumulative probability of the right hand side in the normal distribution. And that is the probability that we have to use to find the z value. And z value is found using norm dot s.inv for that probability. So that gives us the z value. So the next step is to find the margin of error. Margin of error is z times the standard error. That gives us the margin of error. And then p bar minus margin of error is the lower limit, and p bar plus margin of error is the upper limit. So we have the confidence interval now, and we interpret. So we are 98% confident that the proportion of all the automobiles manufactured in these 5 countries with 6 cylinders will be between 10% and 43%. And we need to justify the text within the box. So highlight the box, go to fill, justify, and we are done.